if f of x is equal to 2 sine of 2x plus c, then the maximum value of f of x is what? Now, the maximum is found by taking your midline plus your amplitude. So identify the midline, identify the amplitude. Our midline is y equals c, and our amplitude is 2. So your maximum is c plus 2. I'm not even sure how you would get any other answer choice. Going on to the first Regents question. They want you to graph that equation over the domain below. That's kind of very similar to the question we ended off on yesterday. We're going to go through it hopefully super quick. That way we could get to the harder questions. Now, you do want to find all of your main values. That's going to be your midline, your amplitude, your max, your min, your frequency, period, and your quarter points. And I'm sure many of you guys, if not all of you, are already bored of doing this, but hopefully we remember it. Your midline is y equals 2. Your amplitude is 3. That means if you're starting at 2 and you're going up by 3, you get to 5. And if you're starting at 2 and you go down by 3, you get to -1. Your frequency is 2 because your frequency is found in front of the variable. That means your period, which is 2 pi over your frequency, is going to be 2 pi over 2, which means your period is just pi. Your quarter points are your period divided by 4. So we're going to take the pi, divide it into 4 sections, and that means my first quarter point is pi over 4. Next quarter point, you're counting up. 2 pi over 4, 3 pi over 4, 4 pi over 4. Now that is 4 quarter points, so this means this is 1 full cycle of the graph. But we're not stopping at 1 full cycle because this particular graph tells us to go to 2 pi, and this right here is only pi. So you need to keep going until you reach 2 pi for your domain. That means I'm going to have 5 pi over 4, 6 pi over 4, 7 pi over 4, and when I get to 8 pi over 4, 8 divided by 4 is 2, so this is 2 pi, which is our domain, which is good. So I'm going to plot all 8 quarter points, which is going to be 2 cycles, because every 4 quarter points is a new cycle. And we talked about how yesterday that you don't have to necessarily graph a full cycle or 2 full cycles. You could graph a half a cycle or 1.5 cycles. It depends on how much of the domain how large of a range they give you for the domain. Anyway, we're putting on our basic values. I'm going to count every 2 boxes because I don't want to be too squished in. There we go. If you need to pause the video to make sure you can label everything, then do so. Along your y-axis, you're going to want 3 main points. That's your midline, your maximum, and your minimum. So we have our midline at 2, and we are sketching out the midline for ourselves, maximum at 5, minimum at -1, and notice how there's 3 boxes between the middle and top, and 3 boxes between the middle and the bottom, which means it makes sense because your amplitude is 3, so everything is placed appropriately. I can't tell you how many people lose points because they misplace a spot on your grid, not because they do actual math wrong. Now, this is a positive sine curve, so we're starting at the midline and we are going upwards because it's positive. So we're starting at the midline and we're making a shape that looks like that. I'm going to go up to my maximum, come back down to my midline, come down to my minimum, back up to my midline. That is one cycle. And I'm going to repeat the same process. Come back up to your maximum. On the next quarter point, go to your midline. Next quarter point, go to your minimum. And then you end on your midline. Can we please stop drawing random curves? You need to plot the points first and then connect them with a smooth arch. And you're done. This is worth 2 points. Going on to a more difficult question. A lot of times with trig, they're going to make questions that have to do with real life examples. So in this case, we have the resting blood pressure of an adult patient can be modeled by the function P below, where P is the pressure in millimeters of mercury after time t in seconds. Now they're telling us to graph P of t over the domain from 0 to 2. So please make sure that you don't stop until you get to 2. And if you notice along your x-axis, this is 0, this is 1, and the 1 is 6 boxes away from 0. So another 6 boxes away, 2 would be there. You can't change the scale if they gave it to you. With respect to the 90 on the y-axis, we're going to come to that in a bit. You need to find all your information in order to graph this. So we have our midline, amplitude, max, min, frequency, period, and quarter points. Your midline is what you're adding on. So in this case, the midline is y equals 120. Your amplitude is what's in front of the trig function, which is 24. So if you're starting at 120 and you are going up by 24 units, we are reaching a maximum of 144. Your minimum, if we are starting at 120 and we go down by 24, we are going down to, I believe that's 96. Now, when you go and you put these values on your x-axis, what this little break means is that we're starting at 90. They're just not showing you the graph from 0 to 90 because counting from 0 to 90, there's nothing there. We don't care to look at it. That does not mean every box is worth 45 or every 2 boxes is worth 90. This is saying we're starting from a blank slate at 90. So you just need to make sure that you go from 90 and you count upwards and make sure 144 is on the graph. Now, you can choose to count this however you want. You could count by 5s, you could count by 10s. I don't really care. You're just going to have to estimate it because then you're not going to have the important numbers like 96 and 144 on your graph. I would personally count by 6s because your minimum is 96. Like, I want to have that for myself on a box because I don't like estimating. So I'm going to make this 96. This is going to be 102, 108. I'm just counting up by 6s. 114. I get 120 on there, which is really nice. And that's my midline, so I'm automatically going to go and make my reference line. I have 126, 132, 140, and I have oh, no, that's not 140. 132 plus 6 is 138, and this is going to be 144. So the only values we truly care about are 144, 120, and 96 because those are my max, my mids, and my minimums. From there, I'm going to go and find the frequency, which is 3 pi. We haven't done a frequency that actually had pi in it up until now, but that's okay. Our frequency is 3 pi, which means your period is 2 pi over the frequency. So 2 pi divided by 3 pi is going to give you 2/3. Your quarter points, we have our period divided by 4. You're going to have 2/3 divided by 4. Now, if you need to do that, you put it in the calculator, but you should be able to do it without one. 2/3 divided by 4 is really keep the first fraction, change to multiplication, flip the second fraction. Keep, change, flip. So 2/3 divided by 4 is really 2 over 12, which simplifies to 1/6. And again, if you need to, use your calculator. If it gives you a decimal, you're going to hit math frac to turn it into a fraction. But if you use alpha y equals to put it in as a fraction to begin with, it'll give you your answer as a simplified fraction. Anyway, we have 1/6 as your first quarter point, so the next quarter point is 2/6, 3/6, 4/6, and that is our first cycle. Then we have, because I need to keep going until I get to 2, I need to keep going until I get to 12 over 6, which is equivalent to 2. Then I'm going to have 5/6, 6/6, 7/6, oops, not 76, 8/6, 9/6, and I think I already hit my second cycle. 10/6, 11/6, and 12/6, which is equivalent to 2. So that means that I'm going to have 3 cycles on this one graph. And it's great because all of my boxes are already split up into 6. Now, you don't actually have to go and label each of these because you already have your scaling on the graph. Remember, in general, it's a good point to put your first quarter point on the graph and then the very last marker. If you want to, you could go and put all of those down. I just think it'd be very messy, so I'm going to leave it out. When you go to graph this, we have a positive cosine curve. There's no negative in front, so it's positive. Positive cosine curves start at the max. So we're trying to make something that looks like a valley with 1, 2, 3, 4, 5 main points on it. So I'm starting at the maximum of 144. My next quarter point is the midline. I'm going to go down to the minimum. Once you hit the minimum, you're going to work your way up. So minimum, midline, maximum. That is one cycle. Then I'm going to go to maximum, midline, minimum, minimum, midline, maximum. Maximum, midline, minimum, minimum, midline, maximum. And you're going to try to connect it as best you can. And I can guarantee you I'm not going to do a good job of this on the computer. Oh, see, that was just awful. I am going to pause. Okay, this is what we're going with, because this took me way many more times than I'd care to admit. But my point is trying to make it as smooth as possible. You can see that in my last curve, my last cycle. I don't know what happened there. But do your best to make sure you go through all of the points. And you can actually see 3 cycles here, by the way. We have our first cycle, that would be cycle 1, second cycle 2, third cycle 3. You're not using arrows because whenever they give you a special domain, there's no arrows. Now let's look at the follow-up question. Determine the period of P. Explain what this value represents in the given context. So we already have our period. The period is going to be 2, thirds. And when they're talking about in the given context, you have to go back through the problem and read what they're even talking about. That means this guy. Take a minute to reread it and figure out what the period could be. And remember, the period represents one cycle. So the question that you should be asking yourself is, what's cycling? One cycle of what? So you can be as specific as you want with this. Sometimes being less specific is better. We're talking about the resting blood pressure of an adult patient. So one cycle of I already forgot what it was. The resting blood pressure of an adult patient takes 2/3 of a second. And we're done. On to the next one. Ooh, and which is also conveniently the last one. So we have Griffin is riding his bike down the street in Churchville, New York, at a constant speed when a nail gets caught in one of his tires. The height of the nail above the ground in inches can be represented by the trigonometric function. Remember that instead of trigonometric, they can say sinusoidal, because sinusoidal means the same thing. It just means trig function. F of t equals negative 13 cosine of 0.8 pi t plus 13, where t represents the time in seconds since the nail first became caught in the tire. They want you to determine the period of f of t and interpret what the period represents in this context. So the period represents one full cycle. And the period is also found by doing 2 pi over the frequency. Now look at the equation they gave you and determine the frequency from it. The frequency is what's in front of your variable. In this case, that would be 0.8 pi. Now the pi's cancel out, so you really just have to do 2 divided by 0.8, which might be tricky for most of us. So instead, we're just going to go and use our calculator. If you really wanted to do it, you could do it as a fraction divided by a fraction, which would be 2 divided by 0.8 is 8/10. So if you did 2 divided by 8 over 10, that would work as well. Anyway, we have our calculator. We're doing, first of all, this is a fraction, so alpha y equals, we want 2 in the numerator, 0.8 in the denominator, and you get 2.5. So that's going to be our period. If you would like to leave it as a fraction, you're going to go to math, and you're going to go to fraction, and it's going to give you 5/2. Don't really care either way. So we have 2.5. And the pi's cancel out. That's why I didn't put it in the calculator. So 2.5 what? Reread the question to see if you can tell what we're talking about cycles of. So we're talking about a nail being caught in a bike tire. Tires go around in a circle, and it's periodic because that nail is going to go around. It's going to start from the bottom, right? Because we're talking about the nail getting in the tire, and the nail's going to get in at the bottom of the tire because the nail is on the ground. So we're talking about the nail going from the bottom of the tire around the tire as he's bike riding, and then coming back down to the bottom. So we're going to say it takes 2.5, we're talking about seconds, for the nail to complete one cycle, because that's what a period is, one cycle, around the tire. Done. That looks like around the tine. Oy. That didn't really help much, but we're going to say that is tire. Now they're wanting you to graph at least one cycle. So you can graph more if you want to. I don't know why you would want to. So just do one. If they say at least one, do the minimum effort. Anyway, they do want you to include the y-intercept of the function. That means they want you to start at x equals 0. And notice how they didn't give you any axes at all. So my suggestion is to figure out what all of your values are going to be first. Figure out what values you need on the x-axis. Figure out what values you need on the y-axis. And then you could determine where you need to place these axes. That way you fit everything in on the graph. And as always, we are going to find our main values, our midline, amplitude, maximum, minimum, frequency. Actually, we don't even need the frequency in period now because we already found the period from part A. And we do need those quarter points. So our midline is what you're adding to the equation. That will be y equals 13. Now, your amplitude is what's in front of the equation, but your amplitude is always positive because it's a distance. So the amplitude is also positive 13. If you're starting at 13 and you go up by 13, you're going to 26. And if you're starting at 13 and you are going down by 13, you are going to 0. And that makes sense because we're talking about a tire. And a tire is going to be at ground level. So you should be starting at 0. No one bike rides in the middle of the air. Technically, I guess you can bike ride below ground level if you're like biking through the mud and you know your tire seeps in the dirt. I don't know. That's thinking about it too much. Anyway, we found out in the first half that our period is 2.5. So your quarter points are going to be your period divided by 4, which is 2.5 divided by 4, which is a number I don't care to do in my head. It's going to be 0.625. Let's see if that's nicer as a fraction. Not really. So I would stick with the decimal just because it's easier. I just wrote that wrong, didn't I? Yes, I did. Actually, that decimal is going to be kind of ugly to add. I'm not going to go with the decimal. I'll do it in both. If you want to go with the decimal, it would be, what was it as a fraction? 5/8. So if you were to do your quarter points in decimals, 6.28, add another 6.28. So I keep saying it wrong, but you know what I mean. Oh, 5. Where did I? Oh, dear Lord. There we go. 0.625. So I'm going to add another 0.625. And I'm going to get 1.25. Add another 0.625. And you're going to get to 1.875. And if you were to add another 0.625, you're going to get to 2.5. How do I know that? Because your fourth quarter point should always be your period. The fourth quarter point is one full cycle. Now, if you wanted to do it with a fraction, it's actually pretty simple as well. If you have 5/8 plus 5/8, 5 plus 5 is 10. plus another 5 over 8. 10 plus 5 is 15, plus another 5 over 8. 15 plus 5 is 20. And 20 divided by 8 is 2.5. So you can choose to do this in decimals or fractions. I'm personally going to stick with the fractions because they're smaller to write when labeling your axes. Now, when you go and graph this, you need to make sure that you get up to 26. So you can really put these axes wherever you want. Don't care. Because everything is positive, you could really just make it like this if you wanted to. Does not matter. You could also put your axes over here. Or you could do the normal one if you want, and you could put it in the middle somewhere. Just make sure if you do that, you have to scale the graph appropriately to get up to 26. Because everything takes place in the first quadrant, I'm going to make it so that everything is the first quadrant. We have my x-axis and we have my y-axis. Or in this case, I guess it would be t, since t is your x variable, and it would be f of t. It really does not matter if you choose to go with x or y. Just make sure the important thing is that we're talking about the y-intercept, so it is important that we're starting at 0. Anyway, I have 4 quarter points, and I have a lot of space, so I'm going to space things out nicely. I'm going to do every 5 boxes is another quarter point. Yeah, that fits very nicely. And then I'm going to put my main values, which are 13, 26, and 0. And I think because I did it like this, I might have enough boxes to go up to 26. No, I lied. The graph only goes up to 20, so you might want to count in twos. Yeah, that would work. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 would be here. Now, notice how I didn't label everything because you don't have to. You only need to label the values that you want. As long as you put 1 going upwards, like if I just put 2 down here, that would be fine because you're showing the scale and they can then assume that 26 is where it is. Anyway, we are putting your reference point at y equals 13, which is, if 12 is here, 14 is here, 13 is in the middle. Let's pretend that's in the middle. Anyway, that would be y equals 13. You don't have to label it, but I just did. Now, looking at the graph, this is a negative cosine curve, which means we are starting at the minimum. We're doing something that looks like a hill. And our minimum is at 0. My next quarter point is going to be up to my midline because I'm trying to follow this graph. Next quarter point is going to be at the maximum. Once you hit the maximum, you come back down to the midline at the next quarter point, and you should always end where you started at the bottom. When you do this, just make sure you don't make it a U or a V because those are ugly and those are parabolas / I guess a V would be absolute value. Anyway, you're fanning out along the bottom. So that's going to be the height of the tire as you go around the wheel while he's riding. And that's it, which is good because my battery is low. Anyway, Tomorrow we're going to be working on what the graph of tangent is going to look like.